Welcome back, car and tech fans. Today we're continuing our mission to make these completely custom Arduino gauges for my 350Z. The goal of this video is to link up our screen with another ESP device which is accessing GPS data so it can send us our speed and then we can plot that on the screen live as we drive around. There are other elements that the screen requires, such as the RPM that we're going to be taking from the CAN bus, but I'm still waiting on the CAN bus decoder to come through. So we're going to save them for a little bit, and we're just going to concentrate on GPS data for right now. Now, I am actually recording this video at the very end of having done all of the work, and I can tell you now, 90% of this video is going to go very smoothly, and then 10% is not. And right now, as whilst filming this, I've spent probably 2 days being incredibly frustrated by something that I cannot get fixed. Fortunately, like I said, 90% of this is working absolutely great. And at some point during the video, you'll get to see it out in a car doing speedo things, which is awesome. But yeah, there is going to be some frustration, and as of right now, I still don't know what the answer is. Let's just catch ourselves up from where we were. At the end of the last video, we'd used LVGL on these WaveShare 2.1-inch touchscreens, and we got the UI looking basically how I wanted it. I did mention that these weren't the final screens that I was going to be working on because they're actually too large to fit into the space on my 350Z. And as the very first step, we're going to see here, they've been converted from using those screens to using these new ones. This is a really simple 2.1-inch round TFT non-touch screen with a 40-pin adapter, and attached to it and driving it, we have an ESP32 S3 W Room IDE board. So this is just a board that has an 18 and a 40-pin LCD driver in it. The board and the screen, I've got 3 of each, were supplied to me by AliExpress. So thank you very much for them sending me the components that I needed for this. I have linked them below if you want to pick them up. So the first thing I had to do was migrate the screen and everything that we'd done from the WaveShare 2.1-inch to these new screens. And that in itself was very problematic because there's basically no existing drivers and setups that are for that screen with that board to do what we want. It doesn't exist. So I had to make it. If you want to get your hands on this full setup that we're going to have by the end of this video, the link is down below and you can grab everything from the repo, which will include the setup for this board. When I ended up getting the setup for this board correct, there were 2 decisions. Do I want to do it with ESP-IDF and use Visual Studio Code, or do I want to do it with Arduino native IDE and keep it a little bit more simplistic? And I decided for a lot of reasons to go for the latter and actually do everything in Arduino IDE. So that's the setup that we're back seeing using here. Reason being is we're going to need a lot of other things now. So we're going to be using Wi-Fi, and we're going to be using ESP Now, and we're going to be using a bunch of other stuff. And if you use ESP-IDF, all of the out-of-the-box documentation you have for those protocols, message communications, all that kind of stuff, just doesn't work. You can't just take the ESP Now plugin, stick it into ESP-IDF, even as a dependency, and then just use the code as per the documentation. Everything works in a slightly different way, and it makes things really difficult if you're trying to, do things that are a little bit innovative. So I decided to take the more simplistic approach and migrate everything over to the Arduino IDE. Now, it does look a bit more like Visual Studio here because I've applied a theme to it that makes it feel more Visual Studio-y, but this is bog standard Arduino IDE 2.3.4. There have been a couple of small, layout changes because of switching from ESP-IDF to Arduino. The only really one that you need to know is at the bottom we've switched to the setup and the loop, as opposed to using an app main. And the stuff that was in the app main is now in setup, and the loop currently does nothing. So this is where we're at. This is step one, back where we were. And there are a few functions in here like this screen initialization with ESP panel, which are things that are required to get the screen and the ESP-S3 talking to each other properly. It was a bit of an arduous process. As I say, it probably took a full day just to get the screen and the board talking. So you're getting very much the abridged version of the pain that I've been through getting this done. Before we can get the screen board to listen for the information coming in from the external GPS device, we need the external GPS device sending out information that we've extrapolated. So introducing board number 2. So this is what we have for our GPS sending. It's an ESP32 Room 32D, so basically just a standard ESP32 dev board. And up here we have a GPS chip. This is a GTU7, you can see it there upside down, which actually runs off a Neo 6M chip. And then we've got the aerial that's just hanging down over here. Now, these are very simply connected. There's 5 pins at the bottom, which I've just soldered onto some socket inserts. We don't worry about the pin on this very end, but the other 4 are basically the 5-volt in, the ground, the RX, and then the TX. So these 2 are the serial connections. I might be having that the wrong way around there, but what we need to know is that this pin is wired over to here, which is just a little extension under the back to this 5-volt at the bottom. So this 5-volt comes out and then goes across there. Just it's 2 wires to get both sides. The ground pin goes to the ground pin of the board, which is just under there. You can see ground. And then the TX and the RX here go to the TX RX serial 2 on the board, which are pins 16 and 17. You want to make sure the RX from here goes to the TX here and the TX to the RX. So, you know, they flip. One's a sender, one's a receiver. So the sender has to go to the receiver and the receiver has to go to the sender. Makes sense, really. So this is a completely different file, and this has all the code in it just for the GPS sender module. So I'm going to talk you through this. And it does 2 distinct things. 1, gets GPS data. 2, sets up ESP Now and broadcasts that GPS data every 1 second. So let me talk you through this code in 2 parts. First, we'll just talk about GPS related stuff. So we obviously need our standard Arduino plugin. And then the only other one that we need right now for GPS related stuff is Tiny GPS Plus. There are a few different versions of this plugin. I am using, if we look at Tiny GPS, I'm using this one, Tiny GPS Plus ESP32. So it's the ESP32 specific version of that library. All it does is allow us to take GPS data, which comes in a standardized format, and then extract the useful things out of it that we want, like latitude, longitude, altitude, speed, and so on. What we're really trying to do is establish a wired serial connection between the ESP32 board and the GPS chip. And we do that with, starting here, creating a hardware serial to GPS serial 2. Now, GPS serial 2 on these ESP boards is generally pins 16 and 17. We do actually define the pins at the top here that we're using for that serial connection, but we will also set up the hardware serial. If you're using a non-ESP32 board, you'll probably use software serial instead of this hardware serial. But if you're using a non-ESP board, you're not using ESP Now. So chances are you're probably, if you're following this tutorial, going to be using an ESP32 board. We then start our GPS serial, and we need to allocate the baud rate, the kind of serial connection it is, and what the ports are. So the baud rate, again, we set at the top as 9600. They're basically all you're going to need. And this will initialize that connection, that serial connection between the ESP32 and GPS. Then if we come down to the bottom, in our loop, we're just going to check the GPS. And that's got a millisecond checker in here. So I can say how often I want to check the GPS data. At the moment, I've got it running on 1 hertz, which is 1 update every second. So we're going to have that send interval as 1000 milliseconds. So it's going to extract that newest GPS data and send it every 1 second. At the moment as well, the GPS board is set up to extract satellite data every 1 second. So it makes sense to have that in line. So every 1 second, we're going to enter into this format. And the first thing we're going to do is check if the GPS is available. And it's just going to see, is there a connection to the GPS chip? Is the serial connection not severed? It's sending and receiving correctly. And does it actually have any connection to satellites? All of those things, if they're not happening, will mess up the GPS available. If it is available, we're going to use GPS encode, the GPS serial read. So GPS encode is part of this tiny GPS that we set up at the top with the initializer here. And all it's doing is it's a way, it knows how to take GPS data that comes from a serial that's formatted a specific way and extract the things out of it that we need. So then we can access that information a bit more easily. So if the location is updated, so if we're moving, then we want to do the following things. And it's extract. The 2 things we're going to use at this point are the speed in miles per hour and the number of satellites that we're connected to. I'll explain why in a minute. So this is how you get those. It's GPS speed mile an hour, which is actually a float value. So it'll give you it to, I think, 2 decimal places. I'm just going to use it as an int because I don't want to display that I'm doing 14.46 miles an hour. I just want to show 14 miles an hour. So we make an integer of that speed, and we've got the satellites value, so the GPS satellites value. So it's a count of how many satellites we're connected to. A really good connection is around 7, but it'll work from 2 or 3. And if it's not updating, it means either there's a connection problem or we're not moving. So at the moment, just for the time being, we're going to just send satellites of 0 and speed in miles per hour for 0. That's actually all the code that's needed for this data. So if I plug it in, you'll immediately see that the lights come on. I am sat inside with the blinds closed on a pretty overcast day, so there's a good chance this is not going to be picking up GPS signals right now. So if I just go to the serial monitor, there we go. Right, so we can see serial is available, but it's not updating. So what is happening is it's not actually connecting to any satellites right at this moment. Now I can take the board and go and stick it by the window and give it a few minutes, and then hopefully we'll start to see that GPS data come through. So I'm going to do that whilst I talk through the next bit. All right, so that is over sat by the window, and hopefully in the next minute or so we'll see whether or not this is actually going to start receiving some GPS data. But sometimes on a cold start, it does take a little bit of time to start up, which is exactly why I've decided to capture the satellites value and send that as part of the ESP Now configuration that we're sending to our boards shortly. So if we look at the ESP Now part of this, we need the broadcast address. So inside secrets here, I've got this secrets file, which you don't need to see the inside of. It's literally just a bunch of MAC addresses in this format. So if you wanted to use your own, you could just put it in here and put the MAC address in. But this is my speedo MAC address. So it's the MAC address of the device that we're sending ESP Now data to. We need to define, here we go. If we just seen at the bottom, satellites 4. So we've connected, which now, so it's not saying not going anywhere now. It's saying our speed is 0, which is correct because we're not going anywhere. So it started, it took about 30 seconds to boot up, I would say, and get its first bunch of satellites. So we need to define the kind of data that we're going to send to ESP Now, and it needs to be defined the same on both ends of the communication. So we create this structure, and it's going to take an ID, which is going to be the ID of the board that is sending out the information, the number of satellites, and my speed in miles per hour. And they're all just integers, keeping it nice and simple. And then I create that as a structure called structure speed, which is then defined as my speed. They're really just the only custom bits you need out of this. The rest is pretty much default out of the box ESP Now, which is again one of the reasons why it's dead easy to do this in the Arduino IDE instead of something like ESP-IDF, because you would have to massively alter how this code works in order to get it running in that framework. Basically, all you do is you create a new peer object called peer info. We go into our Wi-Fi initialization. So at the start, when we run the setup, we start our serial, we set the ID of that MySpeed object to board ID, which is set at the top. So board ID for this board is 1. Board 1, it's never going to change, so we can just initialize it in the setup. Then we do the Wi-Fi initialization, which starts up the Wi-Fi as a station. Now you can have stations and access points. These are all just going to be stations. That's all we need to do for the kind of communication that we're doing. We initialize ESP Now. If there's a problem with the initialization, we just print it out. Otherwise, carry on as normal. We initialize the callback. So this is the register, the sending callback. So what do we do when information is being sent? And at the moment, we just say whether it's delivered successfully or it delivered failed. And you can see here, they're all doing delivery fail. And that's because my endpoint is switched off. So it's sending them out, but they're not being delivered anywhere. And then we copy the broadcast address, which is the one that we allocated at the top. So the MAC address of our unit that we're sending to, into this peer info object. We set the channel and the encryption. So that just basically sets up it saying, these are the devices that I'm sending to. You can do this inside a loop and have multiple MAC addresses if you want to send to multiple boards. That is something we are going to do as an extension of this in a future video. But for now, just that. And then we add the peer. So this is the ESP add the peer. So internally, ESP now goes, okay, well, these are all the devices I'm going to be sending to. So it's, just sends off to those specific MAC addresses. Then all of this we've set up before, we don't need to look at. The only thing that's going to be new is that when we are setting up the information that we're going to send via ESP Now, we need to do it as part of that structure, as part of that MySpeed object that we've set up. So everything here is just setting the values of that object and then just sending them with ESP Now, which uses this line, which we've used twice here, both exactly the same. And they're just sending to the broadcast address the object that we've set up. And that's it. That's the entirety of this GPS thing built. Again, if you want this code, it's also available in the repo down below for the GPS module. The only caveat is that secrets.h isn't included, and you've just got a blank space here for you to put your own MAC address in. So assuming you've wired it all up correctly and you're doing this, we are now broadcasting speed that is moving every 1 second. So the next step is to update our existing code on the display in order to accept that information coming in from ESP Now. So we're going to just start with the code that we've got, and I'll just update it to do the ESP receiver information and then talk you through that. A lot of the setup of this is basically exactly the same that we did on the sender. So we need to initialize Wi-Fi and ESP Now, set up the structure exactly the same as we did before. It has to be in exactly the same format with the same variable names, just, ready to go and matching. And we this time set structure speed to speed data as opposed to my data, because this module is actually, in the end, going to be getting data from various sources. So we're going to need to be able to differentiate between the data formats and the structures that are used for those data formats. Coming down, we have a new volatile bool called data ready. I'll explain why in a moment. We've got our ESP Now received function. So it's the exact opposite of what we did with the send function. At the bottom, when we do the setup of this page, we've got the screen initialization. Now we have a new Wi-Fi initialization. And in here, we do a lot like we did in sender, initialize this Wi-Fi as a station, initialize and start up ESP Now, and then set a callback. But this one's using received callback as opposed to a send callback. So what do we do when the messages are received from ESP Now. And we have a function that I've got up the top on data received. Again, this is just all straight from the ESP Now documentation. So if you want to go and look at this in more detail, go and check out the ESP Now documentation. But we're taking the incoming data and we're putting it into that speed data, into that the format here that we've got in that structure. So when information is sent in, all we're doing is writing it from the incoming data into that memory value and then setting the data ready flag to true. That's it. There's a problem that people have with ESP Now is you then start to do all of your code in here that starts to do things. And the problem is that starts to then hang up the rest of the system because the ESP Now connection is a serial connection, and anything done within that function, it interrupts the rest of the code. So if you've got something that, say, hypothetically took 2 seconds to execute inside that on data receive, none of the other code, the redraws of the screen or anything else, could function whilst that's happening. So we need to get in and out of that function as fast as possible. So we do the minimum amount of work that we can. And in this case, like I say, it's just setting that data from what's come in, and it's setting and copying that information to the local data store in that speed data object. Then we set the data ready bool to true. That's it. Then the actual update is handled based on the loop at the bottom. So this is internally like managed, and we can just do if data ready. So if we've flagged it as true, reset it back to false because it means we've done updating all the stuff we want to do. In fact, we actually maybe put that at the end just for readability. But then we update the speed with our update speed that we created in the first part of this. It's just the function we'll look at in a moment. And we update speed with the speed that's in that local object. So we don't actually do anything within that serial function. We're doing it within the normal timed loop. Makes things a bit easier. And then the actual function is towards the top where I've got all my set functions. So update speed basically creates a new character because it comes in with new speed, which is an integer. We approached this in the first part. There's been a slight change. I was using memory string copy here, but we changed it to itoa. So this takes in our new speed, copies it to this character. So basically converting a integer to a character. That's what this function does in a base 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rather than base 8 hex or anything like that. So yeah, it's just converting an integer to a character and then setting that as the label. Then we have this current speed is new speed. It's just a thing I'm using to manage the speed around the application. It will become useful in a minute. As we can see, though, on the serial monitor, nothing is happening because at the moment my GPS module is unplugged. So if I plug in the GPS receiver, we should pretty quickly, there we go, straight away, received and speed updated. So you can see it's receiving the speed of 0 from the GPS, and it's saying the speed has been updated to 0 miles an hour. Now, you might notice that some of this text is getting cut off. It's like it's moving on too quickly. I think this is part of the problem I'm having a little bit later on. But in essence, now it is taking the GPS data, sending it by ESP Now, and then the screen is also receiving with ESP Now, taking and extracting that speed, and then updating it accordingly. The fact it shows 0 miles an hour is because it's not moving. In order to see it move, we're going to have to go out in the car. So let's take these two modules out for a drive and see what happens. Right, I've come to this like car park area for a preliminary test. And up here, on the dashboard, I have, this is the GPS sending module, and that should be broadcasting my speed. Then I also have the screen. For the sake of this first test, I'm just going to plug them into a USB here. Yeah, flickering like that, flashing means it's finding more signals, so that's also good. And the speed over here is displaying 0, which is good because we're not moving. I'm just going to put the camera in a mount so you can hopefully see the real speedo down here as well as this one, and we can see how close they are. I'm genuinely a little bit nervous about this because I've spent ages trying to get this working and I haven't tried it yet, and I really want to see. Here we go. So let's get out on the road then and see how they actually get on compared to like real speeds. So let's go to 20 miles an hour on my speedo. So that's 20 on my speedo, and I'm showing 19. Oh, there's someone behind me. Need to go 30. Let's go 30. That's 30 on my speedo, which is showing 28, 29, which seems basically exactly where you'd expect it to be. Expect this one to be a couple of miles an hour slower than the actual regular speedo, because the regular speedo has to account for things like tire size, plus there's a natural inaccuracy that's built into them to basically stop you speeding. But it seems to be giving me basically the right speeds, which is great. One thing I need to check though is it updating fast enough? So it does update like pretty much quick enough. If I sit at 29 here, yeah, and look down at my other speedo, then it's about 31. So I think it's, yeah, you know, accurate. So let's go home and see if we can just make some alterations to this to have it, you know, update that a little bit more quickly. But I think, you know, as a ballpark first test, that's pretty good. All in all, first test, pretty successful. But there are two major points that I took away from that of things that I wanted to do to iteratively improve it that I hadn't thought about during the first design. First one, what if the GPS sender module loses power? What if it's not able to get a GPS signal for some reason? What if the ESP Now connection goes down? All of these things would mean I effectively lose my speedo. Now, it's not too big of a deal whilst I also have a cluster speedo, but at some point we're probably going to build a full new one of those. So it needs to have some form of backup. And what we're going to do, and the reason why I decided to put satellites in here, is I'm going to also track the number of satellites that we're connected to. And if it's none, which means we've got no GPS signal, then we can fall back onto the speed that's coming out of the canvas. But what I want to be able to do is have a visual display that tells me that I'm not currently using GPS signal, I'm currently using wheel signal. So we have basically a warning light that shows whether or not we're connected successfully to the GPS. And this is how we do it. So before I talk you through the code, here's what we've done as step one. We've added this little marker here, which tells me that currently there is a problem with the connection, which is why it's red. It's showing us that there's an issue with that connection. And it can happen one of two ways. Either the GPS is correctly connected and it is sending back that there are 0 satellites connected, or there is a problem between the ESP32 and the GPS itself. So if either of those connections sever, we get this marker. So just for an example, if I now plug in the GPS, we should, after a few seconds, lose the little marker in the corner. There we go, and it's, oh, things were moving, probably because it just started up, but the marker has disappeared, and you can see we're receiving a correct number of satellites. Often when it first starts up, it thinks you're moving for a little bit. I think it's probably because it's trying to triangulate you. It can't decide quite where you are, and when it moves you between different positions, it thinks you've moved slightly and gives you a very slight speed. But That generally stops A, as you start actually moving, and B, as the satellites all lock into you properly. So how did we do this? Most of it's okay. Some of it's a little bit of a pain, and some of it has knock-on effects. Most of it is done with some timers, but other things are done with just like a couple of little checks. So the simple stuff is if we go to the make at the bottom, where we've made all the stuff, we've made notifications, which is just a new icon. So it's the satellite icon, and it uses the Wi-Fi symbol. Few symbols are available in LVGL out of the box. I just went for one of those, just created this style for it. So it uses an icon style, which I'll show you in a second, and we color it red and then position it where I want to position it. So this is just creating that icon as a global element, which then I can, turn on and off as I want. We've got, obviously I said the style. So if we go up to the top, we've got an additional style, which is an icon style, literally just setting the size of it. So you could set the Monster app font size and it will adjust the size of it. We've got a few additional attributes that we're using for this. So there's a timer that started to run. So this is just going to be for LVGL. And then we have this last update time and a timeout in milliseconds. So how long do I want until it realizes that there's something has gone wrong? And then we just have this LV timer updating the last update time every time data receives come in. So new data's come in, we update the last updated time. And in the loop at the very bottom, each time we go into the loop, we're now using the LV timer handler. Don't want to go too deep into that, but it's just a way of managing ticks and timers for LVGL to make sure it has priority for its tasks, and it allocates the time it needs to rewrite the screen properly. Then we run through this ESP Now timeout function, which I've just put at the top again, I believe. There we go. So this is going to make the current time now. So when that loop's going through, it goes through and it gets the current time. If the current time minus the last update is greater than timeout. So basically, if over 5 seconds has passed, we just print that we've timed out. We add a clear flag. So you can do object clear flag for the satellite icon. And we're going to clear the hidden flag, which means it shows. And then we set the speed and the satellites to 0. Then reset the update time to the current time. So it doesn't keep doing it every time. Afterwards, it resets the timer. So it has to wait another 5 seconds. And then it will trigger it again. And then the only bit of this that's a little bit of a pain is the setup of the timer attributes here. So LVGL has its own thing, like I said, for tick timers to make sure it does screen writes properly. Not a thing that is currently working amazingly, but we'll get to that in a minute. We need to set up this attribute for the on timer. And then there's a bit of default code, which you can pull out the LVGL documentation, which is basically this here. So what frequency are we going to be doing? And this is all done in microseconds. So 1,000 microseconds is 1 millisecond. And then basically this is just setting up that timer and making sure that it takes priority. So then that runs with the LV timer handler here in the loop function. And we've got this interrupt that comes in. It's all, we can get into this in a future video perhaps, but I don't want to spend time digging into how timers and tick timers work for LVGL because it's a dark art and I don't know all of it, but this works and it runs, and after 5 seconds it'll do the thing without interfering with everything else that's going on in the screen. And our final thing is in our loop now, whilst we do the data ready, we also do checking if the satellites that we've connected to is greater than 1. Oh, that should be greater than 0. Maybe that's why it was getting speeds but not satellites. So if it's greater than 0, we add the hidden flag, which gets rid of the marker. And then if it's basically not greater than 0, so if it's 0, then we clear the hidden flag so it shows. And that's basically how that works. There are 2 additional things that I want to do to finish this thing off. And one of them has eluded me for 2 days. I still don't know what the answer is. I'm going to show you the problem now, and it's basically because the screen doesn't seem to be able to rewrite that updates fast enough for what I want to do. So I took this out at this point for a drive. My concern was that it updates the speed every second, and it feels a little bit slow. It feels like it's like catching up behind it, and it's not the biggest deal, but it would be nicer if instead of, like, when you put the foot down, say you're at 10 miles an hour, suddenly you're at 16 miles an hour in the next seconds. Instead of jumping from 10 to 16, if it quickly went 10, 11, 12, 13, 14, 15, 16, right? So it did that over the course of that 1 second. And we could do that multiple ways. We could increase the hertz rate of the GPS. So this GPS module will go up to 5 hertz, which means it's sending 5 updates a second, which would be great. And we could do it that way. Or we could take the inputs once a second and then use some maths to say, well, how many steps do we need to do? And then figure out the movement between them. I've tried both, and they're both proving problematic. For this reason, I'm just going to update the code and I'll show you the problem it's having. What I've done for the sake of this demonstration, showing you the problem, is put a new loop at the bottom in the loop here. So we're not accepting information from ESP Now anymore. Instead, we're just doing a loop that runs every 100 milliseconds. So once a second, it's implementing a counter. And yeah, it's going from 0 to 150. And what that does is show us this little thing, and it's ticking up through the miles per hour one at a time. But let's say I don't want it to update once every second. Let's say I want it to update 5 times a second. What happens when I reduce this timer to 200 milliseconds? Let's take a look. And I'll best actually make this a bigger number because we're going to get through it pretty quickly. 999. Take your guess now, kids. Let's see what it does when it's trying to update 5 times a second. It's working. It wasn't working before. Admittedly, as I've been writing this code during this test implementation, I've updated the way I did this timer. And it might have fixed everything. Basically, what was happening here is when I was trying to write this quickly to the screen, it was missing loads of the numbers and just like freaking itself out. But it appears to be working as I want it to. Oh, that's good. What happens if I increase it to 10 times a second? Let's just push it and see what it does. I might have inadvertently fixed it with this new tick implementation because I was using millis, so using milliseconds, and then using the internal ESP timer during my initial build of this. And I was using the internal ESP timer as opposed to the LVGL timer. And maybe those two things were getting slightly out of sync and causing all of the issues that I had. And maybe I've accidentally fixed it. Right, let's try it at 10 times a second to see what happens. If this works, then we're good. Bar one last small change that needs doing. Oh, God, well, I've fixed it. That looks fantastic. The only change that needs to happen now is the fact you can see like the 9s and the, because this is not a mono-spaced font, it feels a little bit wibbly all over the place. So I'm going to replace that with a bold monospaced font, and I'm going to use Roboto Mono because I like it. So last final change by the looks of things, I've done it. Well, that's surprising. Great. All we did for the monospace fonts is do the exact same process that we did in the previous video using the LVGL font converter, download the Roboto monospaced font, and then update it for the versions that I want. So yeah, a few different weights and sizes, which means we've now got this, which is nice and monospaced. Everything's nice and even. and you don't get the issue where the first digit is like wobbling left and right because of the inconsistencies of the space of the left one. And I've just made it go from 0 to 99 on repeat because 95% of my driving is going to be between those two speeds. So it makes sense to make the miles per hour label look good for generally 10 to 99 miles an hour, which is where the crux of the driving is going to be going done. There's one last thing, last bit that needs to happen. And I wasn't expecting to do it, which is why I haven't done it, because I thought I had an issue with this board, and it still might come up as an issue, we'll see. But the idea is I want it to quickly, like it is now, run between two different numbers. So let's say we're accelerating from 20 to 30 miles an hour in 1 second. I don't want it to just go 20, 30. Over the course of that second, I want it to update with each speed as it increases. So when it receives 30 miles an hour, it knows it's at 20, and it takes the next 1 second going 21, 22, 23, 24, 28, 29, 30, and it like quickly runs through those a tenth of a second each. Or if we're going from 18 to 20, it goes 18, and then half a second later goes to 19, and then at the full second goes to 20. So the numbers change more quickly or more slowly, but you see every number, and I think it'll just make it feel a bit less jumpy than it is. And I was having a problem with that when I was doing it before. So we've got to do these two things. We've got to receive new information from the GPS sender. We're going to have to do fake information because at the moment it's just sending 0 miles an hour from GPS. So we're going to fake a range of different speeds being sent from the GPS every second, and then we're actually just going to do the calculation of how many steps it needs to do in the LVGL component as opposed to actually sending it through multiple times. It means everything runs technically 1 second late, but I think in practice and actually feeling it in the car, 1 second is going to amount to nothing. So yeah, let's jump to that being done. Drum roll. There we go. It is basically, you can see it quickly or slowly moving between the number values. It's constantly chasing the value that it's trying to get to as fast as it can. Now, how's that actually been done? The requirement had changes in two spots. First, we spoofed the numbers coming from the GPS sender. So just made this list of speeds that it's kind of like changing between to simulate what's coming every second. And then we just have a millisecond loop. There's looping once every second. And it's basically, you can see at the bottom, it's just sending those values via ESP Now. So it's just spoofing different speeds coming through. And our receiver code, we just added the target speed at the top as well as the current speed and figured out what the transition time is. So really what it's going to do is go, what is our current speed? What is our target speed? And then in the loop at the bottom, it's going to figure out the difference of the speed, which is target speed minus current speed. And doing ABS means it always becomes a positive value. So, if we've got 18 and we're going to 25, it won't go to -7, it'll just go to 7. So that means there's 7 steps. So the interval is the transition time, which we're always going to have as 1 second divided by the steps. And then it goes through those ticks. And then because it knows the timings, each one of those set point, it'd be like 0.1675 or something like that, whatever 1 divided by 7 is. Each one of those intervals, it would increment or decrement the value by 1. So take the current speed up or down by 1, and then just send that to the update speed. And then the satellites is still controlled by that data ready flag. So it's just really chasing the miles an hour at all times. And it seems to be working pretty well. The way we can actually figure out if it actually feels right with this chaser is to go out in the car one last time and use it. So I'm just going to have to switch back this sender here, the spoof sender. So we'll get rid of the spoof sender and put the actual real GPS sender back on. And that will then mean that it's sending real data. We can go out in the car and see how it feels for a final drive. So let's go do that. Okay. I can immediately tell it's better because instead of just jumping from one like number to another, it's going up and down much more quickly. Oh, this is loads better. Let's get out onto the main road. So we get up to, I'm at 30 on the speedo. It is a little bit behind, which you would maybe expect it to be a little bit behind because it's taking that full second behind to catch up. Maybe what I need to do as a final little bit is just decrease the tick. Maybe instead of splitting that 1 second up into the even chunks, it needs to split up half a second. So it does effectively the exact same thing, but it gets to the new value faster. So I think at the moment it's trying to get up to, let's say 20 miles an hour now, but it's only getting to 18, 19, and then the new value's coming in maybe just before it reaches that value. So it's a little bit slower than it should be. So like now I'm at 30. I don't know. It's only ever so slightly behind, but it is, I mean, generally a lot better. The fact that we see every number now as it goes up and down between the different speeds feels loads better. So yeah, that's working great. As you can see, I feel really happy about that. There might be some changes and considerations that need to be done when we start having data coming in from a second source, because we're going to be having the canvas data, which will give us the RPM, and there's also going to be the gear stick, data, which will be giving us the gear that we're in. They're all still to come, so it's going to have to learn to accept inputs from various spots and not get too confused with its redraws. So that's going to be a challenge for a later step. So I guess you're wondering what's actually next. The problem is, like I said, I'm waiting on the canvas sender. Don't know when it's going to be here. Hopefully sometime this month. So we can't do any more on this particular gauge. But what we are going to do next is do the second gauge, which has some of the data stuff in it. And we're going to reuse the GPS sender, and it's going to send information to a second module, but it's going to be sending weather and some other localized data that can display on the second screen. So we're going to increase the usability of that one that we said we were just going to put the time and like the temperature outside. We're actually going to get like weather warnings and current weather outside and like 4-hour lookout on that little screen. So that's going to be really interesting because we're going to have to obviously use the GPS data with live web information, which we're going to achieve using a hotspot through my head unit because it's got its own SIM card and its own Wi-Fi signal. So we should be able to do that way. So next video, like I say, will be setting up the second screen because it's dead simple from a UI perspective and getting all that GPS weather information and some other bits and displaying them on there. So that's going to be really cool. As always, though, if you want all of this code finished as it is in its current state, you can grab it from the repo in the description. If you've got any questions or comments about this, or you would like to see something done a certain way, throw me some suggestions in the comments and I make sure I read them all. And it's really nice hearing all of your feedback about this because I think it's a cool project that a lot of people are going to have fun implementing in their own ways. Anyway, hope that was useful for you all. And whatever you do with the rest of your day, have a wicked one. I'll see you in the next video. Take it easy, peeps. Bye-bye.